Alright. So, good morning everyone, this is Ryan and you are watching episode 61 of my live stream Q&A. So this is going to be a pretty quick and dirty episode because it was just, suffice it to say, I wanted to spend the morning coding and preparing for the live stream, but other things were kind of getting in the way of that. So on the bright side of things, I do have a bit of a lesson prepared to talk about, and I'll basically be rambling about software architecture. But it won't be quite as structured as I was originally hoping, but that's fine. We will have to just make do with that. Anyways, so before we proceed, as usual, I would just like to mention that if you appreciate what I do and would like to see me do it better, then please do consider supporting me on Patreon or PayPal, or we've got various different social media platforms, and of course the Slack group if you're interested. And if you can't afford to donate or anything like that, that's totally fine. But do consider hitting the like button down below if you learned something, and consider subscribing if you haven't already. Anyways, so the only major announcement I have is basically has to do with what I'll be talking about today. But I set out to basically redo the way I build front-end Android architectures. Now, how I approached it, I'll talk about the things that I used to do versus what I do now, and sort of where those changes have come about. And so one of the things that I'll be talking about extensively is a repository called Space Notes, which is an application I'm building. It's mostly completed, but I have to implement some back-end features, but the front end is mostly completed, to be more specific. And what I'll do is I'll talk about that project in particular, and the specifics of that architecture, including figuring out how to decouple an adapter and a RecyclerView and what I'll call a logic class, I'll explain that later, from each other properly, because one of the things which has been kind of a bit of a classically annoying problem in Android has been dealing with the fact that adapters are a rather peculiar kind of class, because they are sort of a more logically based class. They fire events and wire up a whole bunch of things, but they're also really tightly coupled to the view. And so that's kind of the big problem, is whereas I used to basically set up my adapters within the view, within the fragment class, because it was very convenient to do so because of the tight coupling. What I lost in that was the benefits of actually separating concerns, which, as if you've been watching this channel for any length of time, then you know I am almost a perfectionist when it comes to separation of concerns. So anyways, what I'll do is I will talk about that stuff, and we'll talk about software architecture in general. But welcome, we got Benjamin joining us. So I'm just going to fix up my whiteboard here and we'll get started. By the way, so what I'll do is I'll talk about architecture in this project for approximately 20 minutes to half an hour. And if you have any questions, feel free to ask. And I'll either answer them later, or I might jump in if they're relevant to what I'm talking about now. Anyways. So, how's everyone doing today, by the way? So, what I'm going to start by talking about is how my perspective on three-layer software architectures has kind of changed over the years. So, we're all very, I'm not sure how well I'm going to be able to do this because I'm a lefty, but something which I'm sure everyone is familiar with is the primary what I would call the most common ways to talk about front-end GUI architectures is either going to be MVC, MVP, MVVM. Okay, so I know those aren't especially easy to see, and I don't have the best rating, but we've got ModelView Controller, ModelView Presenter, ModelViewModel. So recently, Google basically, or the Android team, threw their weight behind ModelView ViewModel. It's how they recommend you do front-end architectures on Android. So I'm not going to, normally I would launch into some rambling about why this one irritates me, but I'm going to kind of skip over that. And what I instead wanted to focus on today is to encourage everyone who's struggling with understanding three-layer architectures that no matter what you call those things, whether it's this or that or whatever, a ViewModel controller, presenter view, or ViewModel, ModelView ViewModel, or something like that, what it really comes down to is three primary kinds of code. I'm not going to use big words. I'm going to explain it quite simply here. Three kinds of code, and this is the basis by which we decide to divide them into different architectural layers. So, let's talk about the first one. And this is the most ambiguous of the three layers that I find myself talking about. So we have this thing that I'll call logic. And logic is basically, let me write the three layers out and we'll go through them kind of layer by layer with an extra twist. So we've got logic. We've got like a mini layer in here, which I'll talk about later. Then we've got view. Yeah, I get the order is mixed up. I don't really care. And then we have model. And I'm not actually going to call it model. I'm going to call it data. Okay, so we've got our logic, view, and data. So when you're looking at traditional three-layer architectures, the thing that you really need to keep in mind is that regardless of what you call it, these three layers, if you're following what is known as separation of concerns, these three layers will either be logic-based, which means they tell other components what to do, they dictate the flow of the application, they handle events, that kind of thing. If something has a life cycle, they're going to be listening to that life cycle usually. Kind of the list goes on. Then you have the view layer, or whatever you want to call it. So what is view? This one's very simple. We all know what this is. It's just user interface code. It's the code to draw the user interface, and that's pretty unambiguous. And then we have what people like to call model. Model is, the way I would explain model is that it refers to a model of data or a model of real-world information. What do we do in applications? We represent real-world information in models. So typically we could be talking about just like a class called note, which has the ID of the note, the content of the note, and the person who created the note, or whatever time the note was created. Let me just double check to make sure all the sound's good and everything. All right, yep, looks good. So, so it could be one of those small little classes, which I'll show you in a minute, or it could be like the whole persistence layer of your application. So we could be thinking databases or even a remote database, so then it could be a REST adapter. So whatever, it always has to do with data of some kind, data access and storage, data modeling. So these are the three principal layers. Now there's one more layer which doesn't get talked about nearly enough. And I actually consider it to be a subset of the logic layer. So I'm actually just going to kind of make that a dotted line, and you probably won't be able to read it, but yeah. Okay, this kind of intermediate layer is what I would call build logic, B-U-I-L-D, build logic. So it's still logic. It's still going to be based on life cycles. It's still going to dictate application flow, but it's a subset of logic which just has to do with building things. This is where you would basically see a dependency injection apparatus. What a dependency injection apparatus is, whether you use Dagger or you write your own, which I will demonstrate, At the end of the day, that is what I call build logic. It is the logic required to assemble and wire things together. It's still logic, pretty much. So, from here on, whenever you see anyone telling you that they're doing ModelView Controller, they're doing ModelView Presenter, they're doing ModelView ViewModel, the thing that I really want you to pay attention to is, do they actually separate the concerns of the architecture? So for example, let's say we have something called a view model. A view model. Okay, that's a little ambiguous. And people have different definitions of what a view model is. Some people think the view model should be a logic class. It basically exposes data for views to observe without directly referencing any particular view, and then it'll query the model, or data as I would call it, for the data it needs. So I don't have an issue with that. If you either use ViewModel as a logic class, if it's also a front-end data storage device, which would be in the data layer, and it's also kind of dictating the flow of the application, I don't really like that. And that is the main problem I see with most people doing ViewModel. But the point of this discussion is just to say, the goal of actually following an architecture, in my humble opinion, is to actually separate these fundamental types of code, to keep them separate. So if we have something we call ModelView ViewModel, and then you have classes which cross these barriers, which do both things, then in my perspective, some refactoring might be in order. Now, people have different ways of getting around this with ModelView ViewModel in particular. Sorry about that, I just knocked my microphone over. That was probably really loud, apologies for that. So, people have their own ways of going around. So in ModelView ViewModel, we could have a view controller object. So we have we turn this into MVVM plus VC for view controller. I know that's really hard to see because of the glare. In ModelView Presenter, well, one of the problems with ModelView Presenter is, in what I experienced, is that it's kind of annoying to figure out, well, where do I save front-end session state? Where do I save the current state of the view in ModelView Presenter? Do I save it in the back end? Well, yeah, I can query the back end every time I need the front end state, but do I really need to do that if the user just tilts the phone and the view is recreated? Do I really need to be asking the data layer for fresh data every damn time? Not really, in my opinion. So then we get a situation where we have something like I do. If I were to try and describe what I currently do in these terms, which in a moment I'll talk about them without these terms pretty much, then we would get something like ModelView Presenter plus a view model. Now, when I say plus view model, I don't mean something that is coordinating other parts of the application. There's no logic in here. If you do ModelView Presenter and there's significant logic in your view model, then let's just say that's pretty silly. I don't want to say mean things. So, what is all this rambling about me? What is all of this rambling about? Because you can see I'm incensed and I'm rambling about software architecture, and I'm rambling about these things being either poorly defined or just implemented in a weird way that doesn't apply separation of concerns between the fundamental layers, X, Y, and Z. So here is what I would suggest to people who want to learn software architecture. First off, what I would suggest has been kind of the main thing to look for is just the separation of concerns. Whatever architecture you're looking at and whatever people have labeled it, I just want you to be aware. Do you have a class which mostly does logic, but it's also administering directly to a database implementation? That's not separation of concerns. That's not code to an interface. That's not solid. That's not any of that stuff. So what do we do then? Because I remember about 2 years into my experience as a software developer, I kept asking the question, what's the perfect architecture? Should I do ModelView Presenter? Should I do ModelView Controller? Should I do ModelView ViewModel? Which is the best architecture? If I were to try and answer that question to myself from 2 years ago, I would probably say, Ryan, pick one and just make sure you're actually separating your concerns, and then just don't worry a whole lot about what you decide to call them, because it's not actually that important, to be perfectly honest. For the main reason that developer A and developer B and developer C, typically speaking, have slightly different definitions of each of these acronyms, definitely implement them slightly differently or very differently, and oftentimes they don't even actually apply separation of concerns. So what I will do now is let's go through some code, because I'm sure you're tired of the rambling, to see, okay, this is kind of how I would personally suggest you build a front-end architecture, which will be something kind of similar to that, except for today, I'm not going to use other people's words. I'm not going to try and make it overly complicated. I'm just going to try and explain to you what each part of my front-end architecture looks like, so that it might hopefully clear up a couple, it might hopefully clear up some confusion for you. So with that, I'm just going to run a quick commercial break, and we'll jump into some code examples. Okay. Well, I'm glad YouTube is actually letting me run ads today. The last live stream I did, for some bizarre reason, it just wasn't letting me run ads, so it was kind of like, okay, well, yeah, I guess, fine, YouTube, whatever. Don't let me make money. Okay. So let's get into some code now. So I don't have the link up for this repository just yet. It will be available soon. But let's get started here. So what I wanted to talk about is what I currently do, the objects I currently use, what I call them, and what they do. So again, we're going to go through kind of the main 3 layers. I'm going to talk about kind of how I build them on Android, and just kind of go from there, and hopefully it'll be educational, because I do my best with these talks, but like I say, I didn't have much time to prepare today. So first and foremost, when it comes to views on Android, I typically prefer to use fragments. There are a number of reasons why I like to use fragments as views. They're easy to work with. Their API is relatively straightforward. They have a life cycle, which the life cycle callbacks are called by the operating system, so I can kind of use that as like a starting point with which I can decide to pretty much invoke all of the rest of my architecture based on that life cycle callback. So what does that kind of look like? For starters, I've used Kotlin synthetic methods so that I don't have to use data binding, I don't have to use Butterknife, I don't have to use FindView by ID. So if you're in Kotlin, consider looking up Android synthetic properties, they're called. And that'll allow you to literally just directly call anything you want by its ID. So I have not called FindView by ID on this RecyclerView. I just call it as a synthetic property of the noteless view object, and I've imported it up here. So that's kind of how that works. When I want to tell the logic class, which we'll talk about in a moment, this would be what other people would probably call presenter or controller or view model. Then I basically have a single callback to the logic class. I actually have another one. I have So logic.event, and then notice this is an abstraction, this is an interface. But I've got logic.event, and then I have logic.bind. I also tell it to bind. Bind is kind of like the first rendering and wiring up of everything, so I've chosen to keep that one kind of separate. So how does this logic.event thing work here? So for each of my front-end features, I have, let me just pull it up here, list. I have a contract class, which basically lays out the different, pretty much the front-end architecture for each individual feature, interfaces for ones that require them, and this is basically a giant source of truth for each front-end architecture. And I actually kind of build these in tandem with unit tests, and I just find that works really well because I have one main source of all the different interactions that I need to represent in Mach, and it works really well. Some people were complaining about having front-end interfaces being not necessary, and to me that sounds very akin to saying that unit testing is not necessary. Yeah, you don't need it. There's other ways to test, there's other ways to do things, but I actually really like having this kind of group of interfaces to describe the front-end architecture of an individual feature of my application. If you structure your application differently, maybe this won't make sense for you, but I find this typically makes sense. So we have the view, we've got the ViewModel, we've got logic, and then we have these note list events. So I have a little sealed class down here. And so each potential event that can propagate from either the view, in this case, or even the adapter, there's actually no, the adapter calls back, no, sorry, I do actually have the adapter as well call back to logic through this event method. But basically the gist of it is I have an object down here to represent every potential event which can occur in the front end. And how I actually handle that then in the logic class is I have, and this is where Kotlin really shines, I have this event callback which receives some kind of event, which may, in this case, it may have an int. There's only actually one callback which actually requires a value, so that's why I did slap in that little int annotation, but most of them are just plain objects, and I just want to know which object it is, and the way that I choose which object it is using the is keyword in Kotlin. So basically I have one or two methods total, but for the most part all of the interactions in my application from the front end are represented as events which the logic class will handle. So that leads me to the logic class. What does it do? Basically what it does is it handles events from the view, from the adapter. There's a RecyclerView adapter in here as well. And the model, the back end. It creates requests for each of those objects. The one thing it's never allowed to do, actually there's kind of two things, but the main thing it's not allowed to do is it never state. It never stores application state or view state. Yes, it does store a reference to the view, it does store a reference to X, Y, and Z, but it doesn't actually hold state. That's really important. This thing is something which you feed state into as an event, and then you see what it does once it's done manipulating that state. And so what that results in is I have a class which doesn't have any Android imports to it. So there's no Android classes in here. As far as I'm aware, this thing technically extends an Android class, but whatever. The adapter, as I'll talk about in a minute, adapters are just annoying. They're just annoying to decouple from the rest of your architecture because they're tightly coupled to the view. And you can't really get around that easily. But basically, yeah, this is what we have for the logic class. This is what you would normally see called a presenter. It's a logic class. It makes logical decisions. It's driven by logic. It doesn't store things and it doesn't draw things. So that's I could go into a lot more detail, but that's the basic gist of this logic class. Now, if you're into unit testing at all, you'll notice if you navigate to let me find my spot here. I'll open up, actually, why don't I just open it using the quick method. Let's say test. So if I open up note list logic test, you're going to see that all of the different events which I've represented in this contract class, so on new node click, on login click, on toggle public mode, on start, they're all represented as unit tests. Oh, my test class disappeared. They're all represented as unit tests. Sometimes they can start with different values. So in this case, I've got a unit test that says the user is in private mode, so do special things when the user is in private mode and on new node click. Then we have like on new node click B. So this is when the user is logged in and in private mode. So then I want to do something slightly different. So basically what I'm doing is I'm compressing all of the logic of my application. I'm pulling it out of the view, I'm pulling it out of the view model, and I'm putting it into this one object which handles most of the interactions of a particular feature. Now, the criticism to that style of architecture is that you can end up with a situation where this logic class would be quite large. And have a lot of tests to write. My counter to that is that the way I design user interfaces and applications is with a very separated feature-oriented approach. I don't like having massive quantities of subviews. I would prefer to have one view with many individual elements that I can change instead of writing the logic to swap and redraw a whole bunch of views. You can certainly do the view swap approach if that works for you. It's just understand every time you're swapping around views and doing that kind of thing, you need to write the logic to properly handle that. And depending on your situation, that logic can be really annoying to write and buggy. Just hard to capture all the different use cases. What I mean by that is suppose we have a feature that has like 4 subviews, and those subviews are dependent upon certain values which might be at various stages or could be various different things, and then when the user tilts the phone, you need to redraw the appropriate subview out of the 4 that exist with the appropriate data, and it can just get a little tricky. You can do it that way. I'm not saying that's necessarily a bad idea. I'm just explaining why I kind of try to keep my features pretty much contained to one screen, even if it means the logic to coordinate that one screen is fairly complicated. That's what I use my unit tests for. So that's my big rebuttal is people say, okay, Ryan, people might say, Ryan, if I follow your approach to architecture, I'm going to get a huge presenter or controller type class, which isn't good separation of concerns. I disagree. It's good separation of concerns as long as everything that's in it has to do with that particular feature. And it's actually really convenient in that sense to kind of have a bit of a monolith in terms of just one particular layer of an application for one particular feature of an application. Because in that particular case, I have one big test suite which basically covers the whole application flow. The end result of that is you do not see, yeah, there is, here and there will be a bit of logic, but you don't see a huge amount of logic in the view. It's really just set stuff. Logic tells the view to do this, logic tells the view to do that, and I just try to keep the view methods as small as possible. They're small enough that I can look at them to debug them, essentially. Whereas if I were to try to go about doing that in this particular application, I want my unit tests for the complicated event-based architecture stuff, definitely. So that's kind of the logic class. Then we'll get into the adapter really quickly. So one of the big problems I had with this particular application is, so the thing about list adapter or a RecyclerView adapter is that just because of the nature of this class that it needs to be able to inflate and bind views from a particular view which necessarily gets destroyed and recreated and so forth, then an adapter class is unfortunately necessarily pretty tightly coupled to the view. So my old approach, let me show you some old ass Java code here, and I'll find some kind of list fragment. Okay, so this is ancient code. This is from 2016, and this is in Java. But how I used to do recycler views and their adapters is I would nest them inside of the view. So as you can see, we've got our adapter here. And then down below somewhere, there we go. You'll see my alarm list adapter implementation. It's basically, you know, it's pretty expansive. It's pretty expansive. It makes my view enormous, which I don't really like. It means that the view kind of really does need logic because it has that adapter in it, and the adapter does necessarily need a little bit of logic, and it needs to be able to inflate views. So this works, but it always used to piss me off because I wanted to just kind of decouple this adapter and just keep it at arm's length, as Robert Martin would say. Keep your plugins at arm's length. So what I ended up doing is I did manage to get it decoupled. What I had to do to get it decoupled is, so luckily I do have a hook to the view through this parent view group, which gets passed by the operating system into onCreate view holder. So that's kind of the way that I can inflate the appropriate views. I still have my note view holder down here. Some of this needs to get fixed. It's not 100% proper. And what I do is I do have like an on-click listener set for each individual clickable item in the recycler view. And it calls back to a logic class through an interface. So this is still pretty decoupled from my logic class. It's annoying that I have to hold it in memory here, but I just don't really see any other alternative to that other than having the logic class like listening to the adapter. Maybe that could be something I could do. I could send in some kind of observable object and just listen for. In fact, I might do that now that I talk about it. But the important thing here, and this is my main goal with this application, and I'll wrap up what I'm saying pretty quickly here, is I wanted to keep the adapter separate, I wanted to keep the view separate, and I wanted to keep everything sort of good old-fashioned separation of concerns while still getting the benefits of using different parts of the Android ecosystem, like the RecyclerView, and then like I will talk about finally, the ViewModel. So what is the ViewModel in this particular architecture? Let's have a quick look at it. It models the data necessary to render the view. That's all it does. We have some live data here. And once this feature starts, the logic class grabs the data from the backend, gives it to the ViewModel. If I need to make sure that the data is fresh from the data source, then I will again just query the backend. If I'm not super concerned about whether the data I require to render the view needs to be 100% up to date, I just grab it from the ViewModel. The ViewModel actually is just another part of the model. It really, in my architecture, I don't even need to call it ModelView Presenter or ModelView, I would call it ModelView Logic. I don't need to, but if I were to show this code to other people, they would probably say, okay, you're doing ModelView Presenter or ModelView Controller. And what I would say is I don't actually need to say plus VM, because to begin with, in my opinion, the word ViewModel should have just been part of the model to begin with, and it never should have made logical decisions to begin with. I understand some people would disagree with that. But in terms of my architecture, It's a view model, so it models what is necessary to render the view. That's about it. So, what we have when all is said and done is, let me just show you kind of a graphic. I haven't talked about the back-end stuff, and we won't talk about that today, because the focus of this episode is just front-end architectures. But this is actually basically why I decided to, what I decided to build here. I basically said, okay, I need basically 3 things, excluding the adapter. The adapter is kind of a special case. Not every feature needs an adapter, but for the most part, I need a view, something to bind the user interface. I need a front-end decision maker. Call it whatever the hell you want. I'm starting to just call it Logic, because to me that's just the least ambiguous name. And then we need like a front-end data store to store session/temporary data. And I call that a ViewModel. And it's this thing. That's all it does. So this is what I like to call ModelView whatever architecture. It doesn't really matter what you call the logic class. At the end of the day, we're talking about a fundamental separation of logic, user interface code, and data storage and access code. And the finer details of how to actually go about doing that will kind of just depend on the feature that you're writing. If I'm writing a very, very simple feature, it actually almost doesn't even make sense to worry about the logic class. If I'm writing a feature which literally just parses some data from a backend source and then draws it on the user interface just like that without any changes, yeah, ModelView ViewModel really shines for that. When you just need views to observe data and render it, that's all you need. But when it comes to more complicated applications, something which I would encourage people to do is to not assume that you need to just blindly follow this recommendation of architecture, ModelView ViewModel, or to blindly follow ModelView Presenter, or to blindly follow ModelView Controller, just because someone told you that that's the best way to do it. So the big lesson in all of this stuff isn't even all the specifics I went into. It's just to say, at the end of the day, try to achieve separation of concerns, and just try not to have classes which cross these layers. Try not to do that. And if you can actually manage to wire your application up while keeping these layers separate, your application will be easier to test. It'll be easier to write. It'll be easier to read. And it'll be more maintainable. It'll be easier to change. There really are a lot of benefits to going through all of this trouble. I'm so sorry. I'm going to hit myself if I keep knocking over that microphone. Yeah, that's basically it. Sorry, I'm busy pontificating, and I'm not actually used to having a microphone, so I'll have to watch that. Anyways, that's my rambling for today, and that's basically it. So, Only Programming asks, is this ModelView Presenter or ModelView ViewModel? The whole point of that talk was to basically explain that it really doesn't matter. It's actually neither, and most people are very confused on ModelView ViewModel. So the whole point of that talk there, Mr. Only Programming, or Mrs., statistically speaking, probably Mr., was really actually just to point out that it doesn't matter what it's called. It matters that you separate all of these things. You're going to hear people say you should do this, do ModelView Presenter. No, you should do ModelView Controller. No, you should do ModelView ViewModel. Don't listen to any of that horse crap. Learn from all of them. Understand that whichever phrase I use, we're talking about logic, view, and data. And that's basically it. So Anyways, I'm just going to run another quick commercial break, and then hopefully there will be some questions. And yeah, if not, I will probably call it a day. Okay, let me just restart YouTube here. Yeah, no problem. All right. Anyways, if you're watching this right now, then it means that you have an ad blocker. So you get to just listen to me ramble. Okay, now the ad's over. All right, so that was basically all I really wanted to talk about today. I did have a question if I could make like a big social media app that contains all the latest technologies. The application I will be demoing to you soon, Space Notes, the one that I just went over, will give you most of what you're looking for. I don't plan to make a social media application, but there will be a social aspect to this particular application, including a Firebase remote database, 2 of them actually, Firebase auth, room, and it will demonstrate online-offline persistence. So, certainly, so what I'll do is I'll just stick around for one more question because I don't really feel like waiting around today, but certainly, Benjamin, please go ahead, and I will do my best to answer your question about backend. Only programming asks cloud functions, question mark. You might already know this, but whenever someone says the word cloud, always remember that that actually just means someone else's computer. It's just, it was funny when someone actually pointed that out to me. Like I used to be, I used to hear that word like, ooh, a cloud, the cloud database. It's up in the ether, and the cloud actually just means someone else's computer. It just means remote. But yes, it will have both a local and a remote data source. Actually, it'll have 2 remote data sources, one for authorization and one for storage of public notes, and then it will have a local room database. I'm counting German style instead of Canadian style. I don't know why. But yeah, anyways. So, I'm not sure if it's just YouTube malfunctioning, but I have not yet received the question, Benjamin. So I'm assuming you're just writing it out, so I'll just wait a moment longer. YouTube has been pretty buggy. Okay, here we go. So, okay, so I am simulating my JSON. Oh, you should use Ben. Hey Robert, Ben, have you heard of Mach? Here, I'll write it out. Have you heard of? Sorry, let me switch to code here. Mach Web Server. Have you heard of this API? Because I think that's exactly what you need. So let me just kind of read out the question Ben had. So Ben wrote, I'm simulating my JSON responses from a server by reading JSON files from assets folder. I'm doing this because I have a limited amount of requests that I can make, but I know that I will probably face some unexpected errors, such as invalid JSON from the server when I'm using the actual code with retrofit. I'm just wondering if you know any good approach how I can simulate it so that I can test it with retrofit. So let me see. Let me see if I have some code I can show you really quickly. Let's go to I can't remember which projects I actually used this thing on, but I'll do my best here. Let me just see if I used it in Android REST tutorial. I can't actually remember. Did I use it? Okay, I think this will be what you're looking for, Ben. I could be wrong. So, now this is old code. This is, yeah, approaching like 2 years old, I guess. So what I would suggest you use, I used this thing before to test my retrofit adapter called, I'll zoom in a little more, Mach Web Server. Unfortunately, it's been a while since I worked with this stuff, but so what it should allow you to do, so what you do is when you create your GitHub, instead of passing it the URL to the actual REST endpoint to your server, what you do is you create a version of your REST adapter and you point it to this thing server.url. So server.url is actually just an instance of Mach Web Server, and you've started it. And then what you can do is when you want to set up a response, then you just do this server.enqueue thing, unless the API has changed, because it has been a little while. And then you can, what I've done is I have just this class here, adapter test data, sample JSON data. So I send it whatever data I want to give it to. So at this point you could create an invalid JSON. Let me just jump into this file and show you what the JSON looks like. So yeah, this is kind of a biatch. I don't think I wrote this out by hand, but what you want to do is you can end up, instead of reading it from assets, I actually just have a class called adapter test data in my test folder, and I basically just create the whatever JSON I want in particular here. As you can see, it's a pretty big ass JSON response. And so yeah, hopefully, I think, Benjamin, if you check that out, that might help you out. You are right. At the end of the day, you're only concerned about testing your part of this application flow, not so much your REST adapter, and you're running into an issue where you have a limited number of requests to that REST endpoint anyway, so you don't want to be firing those requests all the time. With Mach Web Server, you literally just talk to a fake version of that web server, prepare your expected responses from that web server, so there's valid response, empty, you know, I'm sure you'll be able to figure that part out, and hopefully that'll help you out with that. So that's it. And just one last time, that is called Mach Web Server, and it's a handy tool. I will probably use that in Space Notes. Anyways, I think that's about it. All right, so okay, so I am gonna. Oh, no worries, Ben. Ben says thank you. So I'm about to leave, but let me just answer this question really quickly for Robert. Thank you for joining me. So Robert. Robert asks, may I ask, how do you manage your professional and personal projects? Do you use any software? What about Kanban board system? No need to apologize. This is a totally relevant question for my channel, so not an issue there. So what I would, let me write out, here are the tools that I have used in the past. I've used, so Trello for task management. I have used Kanban Flow task management, and recently I have been using Jira for Agile Scrum type stuff. I'll just call it that, type stuff. It's a technical term. And so these are the ones that I would basically use for my professional projects. They're all pretty similar, to be perfectly honest, except for I would say Jira is like a more high-powered system. But to be perfectly honest, I think if you had like a team where everybody was really on the same page, then you should probably do fine with Kanban or Trello. I actually kind of preferred Kanban a little bit more than Trello, but they're both pretty similar. I'm not saying don't use Jira, but it does have a price tag, and my experience with Jira is that I could see it being very invaluable for like a larger team where you really need like 10 people to be 100% on the same page. But my personal experience with Jira so far has been that just with the nature of how I work on my projects right now, it hasn't really been worth the money, but I'm glad I learned it, and I'll continue to use it a little bit. I would recommend it for big projects, so hopefully that answers your first question. So for like professional stuff, I have used these task management systems. If you're working on a team, obviously that's invaluable. If I'm not working on a team, I don't typically use these at all. So to answer the other part of your question is, how do I manage personal projects? I do lots of daily to-do lists. I do lots of long-term to-do lists. So over on the wall is just a whole bunch of papers with goals lists and to-do lists and learning lists and things like that. So my goal with basically management of projects is I want my system to be really easy. If it's really complicated and I need to spend a lot of time just setting things up, I usually just don't bother. Yeah, think on paper. I guess that pretty much answers your question. Hopefully it does reasonably well. So I do use software when I'm working in teams, not so much when I'm working by myself. If I'm working by myself, then I'll typically just write out what I need to do here. Let me just, actually no, I can't share that because can't share that particular thing because it's sensitive info, but yeah, that's pretty much what it looks like. So I'll just check the chat one more time. I'm not going to do any more questions, but yeah, that's basically it. So thank you so much for watching, everyone. I apologize that it's a shorter episode, and as you may have noticed, I was kind of angry and agitated, so my explanation of software architecture was quite aggressive. So hopefully I didn't say anything which I'll regret later in terms of mocking ModelView ViewModel, but you know, that's just how I felt today. So thanks for watching. It's been fun, and hopefully we'll see a bunch of you tomorrow in the live stream, the live coding. So tomorrow I will probably be working on either Catalyst or Space Notes, and I'll take you along with my coding journey. And depending on if I can get it set up properly, then I might actually do kind of a longer episode. Usually I only do about an hour, but if things end up okay, then I'll try to do longer. Thank you for watching, and peace out.